Everyone, you're on A-level maths and this is revision. We continue doing revision in the topic of circles and circle geometry for A-level classes, but if you're from IB syllabus and IB program, SL or HL, that's also gonna be relevant to you. Alright guys, it's all about system of equations, it's all about straight lines, the gradients, and of course tangent lines. Today, I will dedicate the time to explain problem 2 that you can find also in your syllabus and in your A-level pure math 1. So just check it out. It's pretty similar question and pretty similar problem of the level EP and P. So that's why also I would like to tell you that guys, like before that I explained the similar problem except for if you compare with what I have right now and what you had there, it's just a bit different and I also used a bit different approach. Alright, so today we have problem 2. We have two parallel lines. Read the statement of the question carefully. So we need to finally determine the coordinates of points B and D, basically their touching point with the circle, okay? And also finally, as the final step, we need to find out the equations of both line L1 and L2 and give the answer in standard form. Just remember, I remind you that there are two forms, gradient intercept. So gradient intercept is just similar, y equals to mx plus c. We have definitely the gradient and you have c as the y-intercept. However, here you need to be able to give you an answer in this sort of linear form of for two variables x and y, so they connected in a linear form. This is just rearrangement of gradient intercept form into the standard one, okay? Where the crucial things here is that a, b, and c are integers, all right? So I just erased that. Hope you recalled what I'm saying right now, and pause the video, try to do by your own as always. And for those who want to maybe have a little hint, right now I'm gonna give you a general strategy that I'm gonna use there. Okay, that's also maybe it's new stuff in my videos. Maybe it's gonna be really helpful for those who just want to get the general tips how to approach to the problem, and then they don't want to go into details of how technically we need to do that. Okay, so that's why the strategy is very valuable things for not wasting your time for watching complete movie. All right, so later on you will always be able to compare what you've got if you just went your own way with what I have here in my videos. All right, the strategy itself. So the strategy is pretty straightforward. What I'm going to use the fact that we have 3 points B, A, and D. So A stays for the center, and if we connect with the line, so this line is going to be perpendicular to both lines because line L2 and L1, they're both parallel to each other. So that's why the line segment BD is going to be perpendicular. Why? Okay, I'll explain you quick. So first of all, segment AB stays for the radius, and according to radius and relations of the radius and tangent line, because L1 obviously is a tangent according to the conditions, so they're perpendicular to each other. The same conclusion we can make for the segment AD to the line L2, so there is also perpendicular ones, all right? Because they're parallel, so the segment BD in total, in general, it's also perpendicular to both lines L1 and L2, okay? And because they both have the same point that they incidence from that point, you can say that words, okay? So you have the whole segment BD perpendicular to both lines, okay? So that's the first plot that you need to do. The second idea, okay? Because we know that this segment BD contains point A, so that's why we know one point, right? And we also know that the gradient for line L1 and L2 is 3 over 4, so we can conclude that the gradient for this line BD is reciprocal one with a negative sign. So we know the gradients, we know the point A with coordinates that you can get from the equation. So that's why we know the equation of this line, okay? So at this point, we know the equation of the line that contains segment BD, all right? So we know this equation, similar to this fact, for -4 is 3x plus some c that we also can figure out from point A, okay? And what we can do next, we need to find the coordinates b and d. For this reason, so what we can do, we can use simultaneous equations of what we have for the circle one, its quadratic one, and we combine with the equation of the line. So where I'm going to put, instead of LBD, so I'm going to put y value, okay? So because there's definitely a relation between y and x. All right, so we've got an equation for the line. So we know that, so we know this coefficient c as y-intercept. We also give an equation of the circle, right? So y minus 2 squared equals to 27. And we need to solve that simultaneously. So solve the system of equation by plugging y, the right side for y, into the brackets right here, okay? So then you expand the brackets, simplify, and you got quadratic equation. So quadratic equation with respect to x, okay? So now you will be able to solve, and you'll get two values for x1 and x2. Why 2? Because you have 2 points, right? So it doesn't matter for which point actually you solve, so that's why actually you solving for both points, okay? So that's why there are two values for x1 and for x1 and x2. So you can determine y1 and y2 by plugging those x into the first equation, because it's linear and it's pretty simple, okay? So that's the strategy. So hence you can find out the coordinates of points B and D, okay? So we've done that. Just sort of, we actually went through the main steps, okay, for the solution. So hope you got it. So second part, B. Once we know the points B, let's say for the line L1, and we know the gradient, so we can get the equation for the line L1 in the form, in gradient intercept form, in the way 3 over 4x plus some c value for this line, let's say c1, right? So that to differ from that c, okay? So that's why now we need to define c1. It's pretty easy, just plug the coordinates of point B that we found in part A from here, okay? So that's why we can determine c value, okay? In the same way we can do for line L2, okay? So we can determine the equation in gradient intercept form with C2 by plugging coordinates of the point D. So once we establish those equations in gradient intercept form, I have no doubt that you'll be able to convert into general form. How? Because it's a fractional number. I'm not sure about C1 and C2 if they're also fractional numbers. So you need to get rid of denominators, because otherwise coefficients are going to be non-integer values like fractional, let's say rational. On the top of that, if C1 and C2 are both surds, that's going to be definitely some irrationalities. So it contains square roots, something like this, right? And that's why you need to get rid of those irrationalities from, from this part, okay? So that's why by multiplying by common denominator, you will get proper form where all coefficients going to be integers, and then you transfer everything to one side and having hence values for a, b, and c as coefficient before x and y and free coefficient, okay? And right side will be equal to 0, okay? That's the strategy, and that's the final answer for part B. I hope you got it. So this is my short explanation. If you want more details, just write in comments. But in this case, I'll save you time by just trying to give you the main strategy. All right, so if you want detailed explanation again, just write the comments. I'll try to provide all the steps, all technical steps, if you need, if you require it. So that was problem 2, and I hope you like that. This way, if you appreciate this short approach, just again write the comments. And of course, if you're new here, just subscribe to the channel, like and support the creator of these videos. That was Daniel Dallas, and see you in the next episode.